So for the last three, I just want to remind you, on these ones, the questions look a little bit more challenging, but they're not, okay? They just might take a little bit more time. So they're not more difficult, they are just longer. But it's still going to use the same rule all along, finding a common base. So I look at G here, I've got 9 to the power of x and 1 over 27. So can you think of a base that we might be able to change either both of them or one of them so that they would be common? 3, that's right. So I think we're all cool with the first one. 9 is just 3 squared. That one I can see. But can you change 1 over 27 to a base 3? Three to the negative 3, that's right. Okay, so we can do it in 2 steps. You can do it like this. You could just say, hey, I know 27 is 3 times 3 times 3. And then I can go off and say, well, it says a fraction right now, a reciprocal. I'd like it to be as a common base, so I'll make it a negative 3. Hopefully we'll get good enough of these that we can do that in 1 step. We say, hey, 27 is 3 cubed. Since it's a fraction, we'll put it as reciprocal, so it's a negative exponent, and we get right to that line. Okay, so you see how the strategy is exactly the same. Still finding a common base, but it's using some of the things we reminded ourselves in the warm-up. All right, so now, therefore, 2x equals negative 3, x equals negative 3 over 2. Again, we needed this strategy because there's no way I would have guessed what do I put on 9, what exponent do I put on 9 to get 1 over 27. I would not have guessed that. I would have guessed a negative number because it doesn't surprise me that 9 to a negative number gets me a fraction, but I don't know if I would have guessed 3 over 2. Good? All right. Now, before we go off and do H, I want to ask this question. If I had just written this down, 4 times x equals 500, and I want to solve for x, what operation do I do? I divide, because I want to isolate for x, so I got to do the opposite operation. So I would just divide by 4, and I would get x equals, what is that, 125. Okay? You think the rules would change if the question was this? 4x squared. What would your first step be? No, your first step. Still get rid of the 4, right? You'd be left with x squared. Then you would go further. Okay? Same idea in this one then. Your strategy is to isolate the term that has x in it. Sometimes, like in the first one, it was just a plain old x, so it was easy. This second one, I put x squared. No big deal. You got to isolate the term that has x in it. So looking at our question, H, I've got 4 times this thing equals 500. I need to isolate the term that has x in it. So that means I want this by itself. What do you recommend the first thing I do is? Divide by 4. So we're going to divide everything by 4, both the left side and the right side. And we'll be left with 5 to the x plus 1 over 125. Now the question looks like just like the ones we had done before. Do you suggest a common base? 5. So this would be 5 to the power of what? 3, that's right. 5 times 5 is 25, times 5 is 125. Therefore, we have the same base, so I can ignore the bases and just look at the exponents. Oops, that's a 3. And so therefore x equals 2. Okay, so the only reason I showed you that one, it's going to pop up later. If you've got a coefficient out front, before you isolate for x, get rid of that coefficient, just like we would have in any other situation. Okay, and then I is my favorite one. I need a common base. Any suggestions of a common base? Okay, 1 is an idea, except how do I change 3 into 1 to the what power? So we're bailing on 1, right? I can't change 3 because 1 to the power of 3? No, that's 1. 1 to the power of 4? No. 1 to the power of anything is 1. So 1 is not a good common base. What are you suggesting? Okay. Do a common base of 3. This part's easy. It's obviously already 3 to the power of something. But 1 we can change into 3 to the power of 3 to the power of 0. So that's one little trick that we can have in our toolbox, right, to pull out. I need a common base. I've got a 1. I can change that to anything to the power of 0. In this case, I'm choosing 3. So therefore, 2x minus 2 equals 0, 2x equals 2, and x equals 1. Okay? All right, so hopefully that is mostly review. Maybe you saw a couple of new questions here at the end here, but the idea is all review. So your practice is going to be a worksheet. It's half a worksheet here, and an investigation. This is just afterwards. And this is a purely optional investigation. After you do your worksheet, that's going to be your practice. That's going to be the stuff you're going to use quite a bit. But this investigation just gets us thinking about what the graph of an exponential function looks like. Remember, in each of our studying of the functions, we've looked at how do we solve them, what are the things about them, and how do we sketch them. So eventually we're going to be sketching exponential functions. This investigation does that. But your number one priority would be the worksheet. And for those of you watching the video, I'll make sure that the worksheet is on Moodle. So good luck.